Section 8.6, we're looking at identifying special quadrilaterals, basically identifying what type of quadrilateral we have. We've talked about every type that's out there, and now we're looking at their properties, what makes a quadrilateral a certain type, and we're going to kind of summarize everything we've got in this section or chapter on quadrilaterals here. And the first thing I want to do, and this is going to be a big slide here, I want to create a quadrilateral flowchart with properties for each of them. So a flowchart kind of has arrows and sort of a logical progression. So I'm going to start out, and we're just going to title this quadrilaterals. Now, in general, the only thing you know about a quadrilateral is that it is a four-sided polygon, right? Except we've talked about a lot of special types of quadrilaterals, a lot of different types of four-sided polygons. So from here, I'm going to arrow over. Now, we had one main category that actually had even special types under it. The first thing we started talking about, most important type of quadrilateral, is a parallelogram. And there are a lot of special properties with this, so we're going to have to list them all here. Now, by definition, a parallelogram has opposite sides parallel. And I mean both pairs opposite sides parallel. I'm just trying to abbreviate things. We use a symbol for parallel. And let's draw an example of a parallelogram here. Okay, opposite sides parallel, let's mark that. So I'm going to do two arrows on these opposite sides and one arrow here. But that's not the only thing that we know about parallelograms. A lot of special properties. We know that opposite sides are congruent. Two tick marks and one tick mark. So I'm going to write that note down. Opposite sides are congruent. Don't we know something about opposite angles as well? Opposite angles are congruent. I'm going to do one arc for these, two arc for these. Next property, opposite angles are congruent. Something else we know that I'm not going to write down, but we know that consecutive angles have to be supplementary, right? The angles next to each other have to be supplementary. Maybe I will. Actually, I'll jot it down, but it's not really possible to put that in the diagram. It's something we have to know. Consecutive angles are supplementary. And actually, the last one here is that the diagonals play an important role too. What do the diagonals do to each other in a parallelogram? They bisect each other. So I could have three tick marks here and here. And I'll do an IV for Roman numeral 4. And I'll write diagonals bisect each other. Whew, so that covers everything under parallelogram. We had all those special properties, and I tried to mark everything in there. Now, under parallelogram, we actually had three more specific, I guess, types of parallelograms. We had rhombuses, rectangles, and squares. And there's one that's the most particular. And I'm going to do two arrows out because I'm going to also, I'm going to do rhombus and rectangle here. Now they get an arrow off of parallelogram because rhombus is still a parallelogram. Rectangle is still a parallelogram. And by following this flowchart, you realize a rhombus would still have all of these things true. A rectangle would still have all of these things true. So I'm not going to write everything additional there because it's already assumed it's under parallelogram. But what made a rhombus special? What's the definition, first of all? A rhombus is a parallelogram with all four sides congruent. Four congruent sides, also called a diamond. And draw this rhombus best I can here. I want to have four congruent sides. So one tick mark for all of those. What makes a parallelogram a rectangle? It has four congruent angles. And what do those angles have to measure them? 90 degrees. Because 360 divided by 4 would be 90. So here's a rectangle. Now I'm not going to mark everything that we already did. I know for both of these, opposite sides are going to be congruent, opposite angles are going to be congruent, consecutive angles, supplementary, diagonals bisect each other. But there was something additional in each of these for their diagonals. In a rhombus specifically, the diagonals meet at an interesting angle. My picture is not perfect, but the diagonals do meet at a right angle. Also, basically all 4 of the smaller right triangles that you formed are congruent, so the diagonals do something else. Jot this down here. Diagonals are perpendicular, and since all these triangles are congruent, the diagonals do something to the angles. I'm going to extend this page. Diagonals actually bisect the angles of that rhombus. So now we have one arc here and here, and since opposite angles are congruent, this original angle would have been congruent to this one, so I can do one arc for both of these. And then each of these guys is getting 2 arcs, because these angles are bisected, but the angles themselves were congruent. I know this writing is getting tiny. In a rectangle, there was one interesting property additional about these diagonals. For the first time, a rectangle is not tilty. My very non-technical term there is not tilty. And so the diagonals themselves are congruent. Now I know the diagonals bisect each other, so I can do 1 tick mark here and here, but now I don't need to do 2 tick marks, I can do 1 tick mark. If the diagonals are congruent themselves, we got that rectangle. Diagonals are congruent, because it's not tilty. And from there, I'm going to draw an arrow from both a rhombus and a rectangle, because if you combine a rhombus and a rectangle, what do you get? You get a square. So a square fits as a rhombus and a rectangle, which is also obviously a parallelogram. It has all the properties of a parallelogram plus all the properties of a rhombus plus all the properties of a rectangle. I don't actually need to draw it because there's nothing additional there, but just keep in mind that all of these things are true for a square. And then I have to go back up here and go from a quadrilateral to a different category. All of these were parallelograms. The next thing that we talked about trapezoids. Now, by definition, oh, my OCD is kicking in. I did everything in blue here, so I better do that again. By definition, what is a trapezoid? It has one pair of opposite parallel sides. So trapezoid, if it has these 2 parallel, there we go, 1 pair of parallel sides. Now the only thing that we actually know about a trapezoid is some of the terminology. These are called bases. These 2 sides are called legs. This would be a pair of base angles. Here's another pair of base angles. We know that each opposite set of base angles is supplementary because of the parallel lines. But actually from trapezoid, we had one special type of trapezoid which became much more interesting, which is an isosceles trapezoid. Now an isosceles trapezoid had congruent legs. So it's still a trapezoid. We still have that 1 pair of parallel opposite sides, but now we have congruent legs. And the other cool thing that was a property of isosceles trapezoids is that the diagonals are congruent. If you think back to the original trapezoid, this diagonal will be longer because it's extended out further with this length than this diagonal. But once you have isosceles trapezoid, the diagonals themselves are congruent. So additional property that is true. Also, in an isosceles trapezoid, just like an isosceles triangle, the base angle pairs are congruent. Base angles are congruent. So I can do 1 arc here and here. These angles are congruent. And 2 arcs for these top 2 angles. Those are congruent. Okay. And one more type of quadrilateral here. Where can I go? I'm going to select all of this and move it a little bit here. Oh my goodness, stop moving. Well, this is a fun game. I don't know why this is still moving. I'm sorry. It's a game of watch this move when I'm not even doing it anymore. Okay, this will be better. I have a little bit of space up here. So off of quadrilateral we had trapezoid, which then led to isosceles trapezoid, and there's one more quadrilateral type that we have not discussed, which is a kite. And it has two pairs of consecutive congruent sides. Meaning that the sides that are congruent have to be next to each other. And I'm going to mark these with one tick mark then, and these with two. There's your definition of a kite. And now we have one pair of congruent angles, here and here. One pair of congruent angles. The diagonals add more interesting features. First of all, they meet at a right angle. Diagonals are perpendicular. The diagonals bisect one of the angles. These two angles here and here are congruent. These two angles here and here are congruent. Remember, we have these congruent little right triangles there. I'm sorry, I'm moving into that next one. Bisect one of the angles. And, let's see, did we get everything? Oh yes, and one diagonal is bisected. We got these being congruent. This is supposed to be 3 tick marks. I'll add this right here. One diagonal is bisected. So sorry for the mess. But from quadrilateral, this is a crazy flowchart. We got all the properties of all these special types. We had parallelograms, and under that, rhombuses and rectangles, which together make a square. We had trapezoids and isosceles trapezoids, and we have kites. Okay, and we got all their special properties listed in this nice little flowchart. So one way to organize this, and you have to know all these properties and be familiar with them, and be able to use all these special properties today. And one more way to organize it. I'm not going to do all the special properties again, but Venn diagrams, you know how they have like bubbles and they can sometimes overlap? Well, if this is a quadrilateral Venn diagram, then we start it out and say everything in this box, these are quadrilaterals. This is the quadrilateral box. Okay. And then I know I had one really big category. Okay, I got to stay in the box. Within quadrilaterals, I had parallelograms. And I put a pretty big area for parallelograms. Because it is a pretty big category. So quadrilaterals in this box, parallelograms in here, and within that, remember there's 3 types of parallelograms. We talked about rectangles, rhombuses, and squares, but a square is a combination of a rectangle and a rhombus. So I need to have an overlap for the next 2 that I do here. So these are within parallelograms. We have in this box, we could say rhombus. In this shape, I could put rectangle. But you mix a rectangle and a rhombus, and what do you get right in here? A square. So that's why they overlap and create a square. And then we have another category of quadrilateral. We had trapezoids. And even within trapezoids, we have a subset, and some trapezoids are a special type of trapezoid. They might be an isosceles trapezoid, so that's within the trapezoid category. And finally, we had that one type of quadrilaterals that's kind of over here by itself, and that is a kite. So cute little Venn diagram of quadrilaterals here. All right, let's take everything we know and identify some quadrilaterals today. One task you're going to have today is they're going to give you some sort of specific category, and you have to figure out what quadrilaterals fit in that category. Here, I have quadrilateral STUV. It has at least one pair of consecutive sides congruent. Consecutive sides being congruent, at least one pair. Consecutive sides. Now, consecutive means next to each other, right, or one after another. So they have one pair of sides next to each other congruent. So think about this. What about the category of parallelograms? Do parallelograms have to have at least one pair of consecutive sides congruent, sides next to each other? Well, no, parallelograms opposite sides are congruent, so I wouldn't say a parallelogram meets that condition. So what about rhombuses or rectangles? Wait, rhombuses, what do you know? All the sides are congruent. So yeah, it has at least one pair of sides next to each other congruent because they're all congruent. So rhombus meets that condition. What about a rectangle? Are the sides, any sides next to each other congruent? Not necessarily. Opposite sides are congruent, probably not the ones next to each other. What about a square? Oh yeah, well a square is a rhombus, so if it works for a rhombus, it better work for a square. All the sides are congruent. So yeah, consecutive sides would be. Trapezoid? Are consecutive sides congruent? Probably not. Isosceles trapezoid, the legs are congruent, but those are opposite from each other. And then that last one was a kite. Oh yeah, definition of kite has two pairs of consecutive congruent sides, so it has at least one pair. So a kite fits in that category as well. So kind of today, like go through your chart or go through all the types and see if they meet a condition. Something else you should be able to do is give the most specific name for the quadrilateral. You want to get as specific as possible, but don't guess anything and don't, I guess, over-insert categories or specifics onto the shape. You have to notice just what you're given, and I guess in here I'm given some diagonals that are, well, first of all, bisected, right? Because I have one tick mark here and here, one tick mark here and here, so I'm thinking the diagonals are bisected. Both of them are cut in half. I see congruent tick marks, but also if it's all one tick mark, the diagonals themselves are congruent too. So they're bisected and congruent. Now diagonals are bisected in any parallelogram, right? That's true always, diagonals are bisected. But when are the diagonals congruent? The diagonals are congruent in a rectangle because there's no tiltiness, remember? Is that as specific as I can get? I don't think there's anything that tells me this is a square. All it is diagonals are bisected and congruent. So I'm going to have to stick with rectangle. I don't know that all the sides are congruent. I don't know that it's a rhombus where the diagonals are perpendicular or bisecting the angles. So all I can do here is say rectangle. It's the best name I can get without assuming anything. Okay. In the next example, alright, I have the side lengths. I'm given two sides are 50, so these are congruent. They're next to each other. Two sides are 51, so these are congruent. They're next to each other. What kind of quadrilateral has two pairs of sides congruent that are consecutive or next to each other? That would be a kite by definition. Okay. Alright, what about this one here? The diagonals are drawn. This diagonal is bisected because two tick marks on both. This diagonal is bisected. Do I know anything else besides diagonals are bisected? I don't see anything else marked. And all you know, okay, diagonals are bisected, that means it's a parallelogram. But if that's all I know, that's all I can say. A parallelogram has diagonals that bisect each other. If you remember back, that was one of the reasons that would let me say something is a parallelogram. I don't have any other specific info. That's all I can say here. What about this quadrilateral? Oh, look, I have these two sides parallel. I have diagonals and I have their measures. Well, wait, one pair of opposite sides parallel, that makes it a trapezoid, remember? The diagonals are different lengths, so this is just a trapezoid. Remember, it is an isosceles trapezoid if the diagonals are congruent. Here, diagonals are not congruent, just a basic trapezoid. So classifying the type of quadrilateral you're looking at. And one more example here. Is there enough information given to show that this quadrilateral is a square? Remember, a square has to have 4 right angles and 4 congruent sides. I see 3 right angles, 2 congruent sides. If there's some way to show that all 4 angles are right and all the sides are congruent, I'd be good to go. Well, maybe there's a way I can show this as a parallelogram. Actually, wait, I have 3 angles. Doesn't this have to be a right angle? Look at me, I'm just writing it has to be a right angle. But why? Don't we know the angles in a quadrilateral have to add up to 360? I already have 90 times 3, which is 270, and this would have to be a right angle. Has to be a right angle because angles add up to 360. Wait, so if this is a right angle, now I know. So this is the first thing I'm looking at. The second thing I'm looking at is, look at this, opposite angles are congruent. So I know that this shape is a what? When opposite angles are congruent, I know it's a parallelogram. I don't know why I did a plural there. Opposite angles are congruent, so it's a parallelogram. Then, so I can say opposite sides are congruent as well. Just remember, parallelogram gives you a ton of info. Once I had all of these being right angles, and once the opposite angles are congruent, now it's a parallelogram. Actually, I guess I should say, if all the angles are right angles, that also made it a rectangle, didn't it? Because all the angles were right angles. So it's a parallelogram or a rectangle, so the opposite sides are congruent. Now, all the sides are congruent, because if opposite sides are congruent, then I also have, one tick mark here and here. Now, it's a square. But I really did have to make sure that all of these things were fulfilled before I can say it was a square. I needed all the sides congruent, all the angles. I had to get to the point where, oh yeah, this is also a right angle because that's the only angle measure left for this quadrilateral. Now the opposite angles are congruent. It is a parallelogram, so the opposite sides are congruent. Yes, we get one tick mark for all the sides. All the sides are congruent, all the angles are congruent. It is a square. So today, summarizing everything, looking at all the properties we have for all the quadrilaterals we've discussed this chapter.